Hi everybody, this is going to be our note for 3.4, solving quadratic equations by factoring. So our goal is to use different factoring strategies to solve quadratic equations. So recall, what does it mean to solve an equation? Solving an equation means to find the value of the variable that makes the equation true. Your answer is then referred to as a solution. So as a quick kind of warm-up example, let's solve for x in both of these scenarios. So the first one's a little bit simpler, I'd say. I want to isolate for x. I'm going to get this positive 3 here. I'm going to move it to the other side. Changes from positive to negative. So across the equal sign, we change the sign. So it becomes positive 3 to negative 3. 7 minus 3 is equal to 4. Which makes sense. If I put 4 into our equation here, the left side will be 7. The right side will be 7 as well. So that makes it true. So x equals 4 is our solution. And how about for this one now? Well, I want to get the 2x squared by itself. So I do something similar. I get this minus 7 here, put it onto the other side of the equation. Cross that equal sign. We change the sign. It's going to be plus 7. So if I simplify this side, 11 plus 7 is 18. I want to start getting the x by itself, so I'm going to divide both sides by 2. I'm left with x squared is equal to 9. Then I can take the square root of both sides because the opposite of squared is just square root, so I'll take the square root of both sides. Oops, I got a little bit ahead of myself. The square root of 9. X is going to be equal to 3. But it could be, again, square root of 9 could be 3 or it could be negative 3. Because remember that 3 squared will be equal to 9, but also negative 3 squared will also be equal to 9. So we can say it can be positive or negative 3. So notice that example A is a linear equation, but B is a quadratic equation. There's only one way to solve a linear function. It's usually just isolating for x because the degree or the exponent on the x is just 1. So it's usually just one way to do this. But some quadratic equations can be solved in two ways. So it depends on how it looks. So let's take a look at this next example. So we're going to do something very similar in example 2 here. It says solve each. X squared is equal to 9. That's kind of what we were doing up here. So as a bit of a reminder, the images didn't really match up, but this one's going to go with this one. This one will go with this one. This means that a number multiplied by itself is 9. What's the number? Can there be more than one answer? That's what we kind of saw up here. Is that if I take the square root of both sides here, I could have negative 3 squared or positive 3 squared. Say x can be plus or minus 3, which means our solutions could be, can I write them over here? We could have x is equal to 3 or x is equal to negative 3. So these are both solutions because both of these can make this equation, make the left side equal to the right side. So these are both of our solutions here. Now what if we have this one? Well, this looks very similar to our factored form that we did before in kind of the last chapter and these last couple sections, where it looks like it's in standard form and I could put it into factored form if I wanted to. So in this example, it's not as easy to find the value of x mentally, so let's try factoring it. We just need to rewrite this equation first. So what we did before was that we'd have a 0 on the end here. And now I'm thinking, well, what can we do to get a 0 on the end here? Well, very similar to what we did up here, we can move things across the equal sign if we want to. So I'm going to move this 5 to the other side. So that 0 will be here because there'll be nothing left on this side, and then everything will be on that side. So x squared plus 7x minus 25 minus 5 is equal to 0. If I simplify this, I get x squared plus 7x minus 30 is equal to 0. So now for me to find solutions, I need to find values of x that make both sides true here. So the actually easiest thing to do is to factor this. So x squared plus 7x minus 30 is equal to 0. Well, I see the value here is 1. So I need two values that multiply to give this, that add to give that. So we could have, it looks like if I wrote out all my factors for 30, 3 and 10 look like they can work because I know I'm going to have one negative number here. Looks like it's going to be negative 3. So that when I multiply these, negative 3 times 10 will give me negative 30. But if I add these, I'll get 7. So these are going to be my two factors, x minus 3 and x plus 10. So what we saw in the last couple sections is after I have my factors here, I can get my factors, set them equal to 0, and then I can solve for x that way. So if I do this, we move this to this side, we get x is equal to 3, move the 10 to the other side, x is equal to negative 10. So our solutions for this example are x equals 3 and x equals negative 10. So again, very similar to what we've done in the last couple sections of just finding the x-intercepts, or finding the zeros, or finding the roots or the solutions. And again, we're going to be looking at factoring again. So if we don't remember how to factor things or didn't learn that before, again, we have to know that for this chapter. So this whole section actually is just us practicing our factoring again and seeing can we get the x values that make these true. So example 3 says, find the roots for each, and then for part C, determine if the given if the given number is a root of the equation. So we have this here, I want to find the roots, so we just have to factor. I see the number in front here is 1, so again, two numbers that multiply to give this, that add to give this. So I see for 6, we have 1 and 6, 2 and 3. Notice my middle value here is negative 5, so odds are that both of my numbers are going to have to be negative. So I see that 2 and 3 here. If I make these negative, if I multiply them, they'll multiply to give 6. If I add them, they'll add to give negative 5. So these will be my two factors here. X minus 2, x minus 3, just doing by factoring. Then I get my x values here. Each factor, we set it equal to 0. And then we just isolate for x, move the 2 to this side, x is equal to 2, x is equal to 3. So these are my two solutions. Our second example, this looks, again, kind of similar to what we are used to seeing, something like this, but everything's on different sides of the equal sign. So first step, let's just put everything on the same side. So I'm going to move the negative 5m to that side, and I'll move the 3 to that side as well. So our new equation is going to be 2m squared plus 5m minus 3 is equal to 0. And now this is just our factoring like before. So here we can use the x trick or decomposition if we want to factor this. I guess I can use, I'll use decomposition, I guess. So I'm going to think of two numbers that multiply to give me negative 6, because negative 3 times 2 will give me negative 6, that add to give me 5. So luckily there's not too many factors, again, that multiply to give us negative 6, so we have 1 and 6, and it could be negative 1, could be negative 6, could be 2 or 3, negative 2 or negative 3. So which pairs of these add to give us 5? Well, just the first one here, negative 1 and 6. If I add these, I'll get 5. And if I multiply these, I'll get negative 6. So that tells me these will be my two things to decompose my middle term here. So I'm going to get negative x and plus 6x. So sorry, I guess we're using the letter m, so I should use m. So 6m and negative m, and then the other sides are the same. 2m squared minus 3 on the other end. Then we common factor the first two, which is just m. Common factor the last two, we'll have 3. Bring our common factor to the front, we get 2m minus 1. Bring our common factor from that one to the front, which is 2m minus 1 as well, because 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. Luckily, these two things in the brackets are the same, so I've done it correctly. I will common factor 2m minus 1 from both of these terms. Bring my common factor to the front. This cancels out with this term. I only have the m left. This cancels out with this term. I'm left with just plus 3. Sorry, when we cancel all these 2m minus 1s here, just a reminder, we have m and plus 3 left. So these two things will go in the brackets. Now you might have done the x trick or the other method to factor this. That's okay. You should get the same answers here though. So again, I'm going to get my two factors, make them equal to 0, and then isolate for that variable. So here we're going to get m is equal to negative 3. Here I'm going to move the negative 1 to the other side, so I have 2m is equal to 1. Divide both sides by 2 to get the m by itself. I have 1 over 2 as my two answers. So if you're like, well, this is just factoring, isn't it? It is just factoring. That's all this section is really. We just have to factor, and then incorporate what we did in the last couple sections, get my factors, make them equal to 0, and then solve for x. And that's all I've really been doing for all of these. Factor, get my factors, make them equal to 0, and then solve for the variable. In this case it was m, not x. Question C says, is x equals 7 a root of this? So this is where we just do a left side, right side check. Where if we're saying x is equal to 7, is it a root? Well, if I put that 7 into my equation here, 7 squared minus 7, if I now simplify and solve this, we get 49 minus 7. 49 minus 7 is 42. So since both sides equal each other here, when I put that number in there, then yes, therefore, x equals 7 is a root, because the left side equals the right side there. So if we did this and we put another number in here, and it didn't equal 42, well then that number would not be a root. So for example, if I put x is equal to 1 there, well, 1 minus 1 would not give me 42, so x equals 1 is not a root. But in this case, x equals 7 is. Our next example says to solve this equation now. So there is quite a bit going on here, it looks like, where I have now things on either side, and it looks like I have some factors, and I might have to do some distributive property here. So we can actually do this a couple of different ways. The easiest way, in my opinion, to solve this is just to first expand everything out, and then we'll have to end up factoring at the very end. So I'm going to expand these out. I'm going to rewrite this out over here. 2x plus 3 squared is equal to 5x plus 3. So this kind of takes into account all the stuff we did in chapter 2, where we're going to be expanding using FOIL and then using distributive property, collect our like terms, and then start factoring. So I'm going to rewrite this. Please don't think we just distribute the 2 into the brackets here. Remember that this means x plus 3, x plus 3 here. And then I will just distribute this 5 in here. I might as well do it now. Get this. So I want to expand this now by using that FOIL method. We're going to multiply first, outer, inner, last. And if we had trouble with this in chapter 2, well, we're gonna be seeing it for, well, this section and probably the rest of the chapter as well. So and the course, so we have to know how to do that expanding by FOIL. So we get x squared plus 3x plus 3x plus 9 is equal to 5x plus 15. I can collect these like terms here. Now this looks like something we can factor. That's because, well, that's what this was. If I factor this, I'll just get these two terms again. So now I will distribute the 2 into all of these. So again, I don't really want to factor this though, because I'll just get this answer again. So once I distribute the 2 into this, 2x squared plus 2 times 6 is 12x plus 18 is equal to 5x plus 15. So now what I can do is, I still have this on this side, but now I have some like terms on this side. I'm going to move everything onto this side. So that again, we have 0 on the one side. So when I move things to the other side, I'm going to put the like terms beside each other, just so it's easier to simplify. So I'm going to have 2x squared isn't going to change much. I have 12x. Then we have the 5x. Then when I move it over, it becomes negative 5x. I'll even just underline this so we can see that that's there. I have 18, and then the positive 15 is going to become minus 15. That's that one there. So now we can simplify this again. I get 2x squared plus 12 minus 5 is 7x. 18 minus 15 is 3, is equal to 0. So this is our new equation here. So I'm just going to move this to the top now. So by putting everything to one side now, it looks like it's in a form that I can factor it, which is what the whole point of this is. Because if I factor this now, because I've moved everything to the one side, this new equation incorporates all of this information. So if I solve for x now by factoring, then I'll have the solution to this equation. So last time I factored by decomposition, this time I'll use the x trick. I have my a value, which is 2, and my c value, which is 3. Again, if you want to use decomposition here, you're more than welcome to, but I used the last method, decomposition, so I'm going to just switch it up a bit. So I need two numbers for our factors here. Again, this is 2x squared. So we're going to have like 2x and probably 1x as our factors, because these multiply to give us 2x squared. And then I'm going to have 3 and 1. Put the 3 here and the 1 here. Multiply these two. I get 6x. Multiply these two. I get 1x. And if I add them together, I do get the middle value, which is 7x. So this will be my first term. Sorry, the equal sign's on the other side. We have 2x plus 1 and x plus 3. And just like before as well, we're going to get our factors, make them equal to 0, and then isolate for x. So here we get x plus 3 equals 0. We move the 3 to the other side. It becomes x minus 3. So this is one solution. And then if I get my other factor, 2x plus 1, move this to the other side, negative 1, divide both sides by 2, x is equal to negative 1 over 2. So this is my other solution. So I think this is the easiest way to do it, and if I wanted to check if these answers are correct, I will put these back into the original equation here, and the left side should equal the right side. I'm just going to do my check over here. So if I have 2x plus 3 squared equals 5x plus 3, first we'll check it for x is equal to negative 3. So if I change x to negative 3, negative 3 plus 3 here, well, negative 3 plus 3 in the brackets will be 0. Same on this side. Anything times 0 is just 0. So the left side does equal the right side. So x minus 3 is a correct solution here. This one's good. Sorry, as you can tell, I made an error before, so I had to resolve it. So we're going to do it for x equals negative half. So I'm going to write my equation again. And I was thinking what my mistake was when I did this, I actually wrote the wrong equation down. So that's why I had to go back and resolve it. So I get negative half plus 3, 5, negative half plus 3 here. When I add these together, I can just use my calculator if I want to. I can use my, if I know how to add and subtract fractions, I can do that too. So let's do 1 negative over 2 plus 3. I get 5 over 2. Squared, this will also be 5 times 5 over 2, because the thing in the brackets are the same. If I square this now, I will get 25 over 4, which is equal to 25 over 2 on this side. Because again, if I wanted to just check on my calculator, 5 times 5 over 2, 12 and a half, or 12 and 1/2, which is 25 over 2 if I did that way. So if I simplify this side now, if I did 2 times 25 over 4, I'm going to get 25 over 2. So now both the left side is equal to the right side here, which means that x equals -1/2 is also a solution. So our solutions are, therefore, x equals -3 and x equals -1/2. So what did we do here? Well, we just put everything to one side. Before I put everything to one side, we had to expand this using that FOIL and then using distributive property, moved everything to one side and collected our like terms, and then we factored. And then we got these answers. Because after we factor these, we set each of our factors equal to 0, get these, and then we don't necessarily have to check, but it's good to check. So I just put my answers back into the equation, so the first solution here and the second solution, and I saw that both the left side is equal to the right side for both of these. So these are both correct, and I just wanted to verify that part. So our last example here is the path of a dolphin travels when it rises above the ocean surface can be modeled by this function here, where h at d, this part, is just the height of the dolphin above the water surface, and d is the horizontal distance, the point from where the dolphin broke the water surface, both in feet. So what horizontal distance does the dolphin reach a height of 1.8 feet? So what we're saying here is if we have the dolphin, and we kind of made a graph here, HD here is how high the dolphin is kind of getting up vertically in the air, and the horizontal distance here just refers to how far horizontally or how far this way has the dolphin jumped. Like this. So maybe this would be 20 meters, 10 meters, 1 meter. I just made up numbers there. I actually don't know how far a dolphin can jump, so but that's what I mean by horizontal distance. How far do they jump this way or horizontally? But the question says at what horizontal distance does the dolphin reach a height of 1.8 feet? So we're saying, well, what is 1.8 feet on this graph? Could be here, could be anywhere. So it's harder to do this by graphing. But we can use our equation here. So we have the equation of h at d is equal to -0.2 d squared plus 2d. We want to find out what the value of d will be, the horizontal distance, when the height is 1.8 feet plus 2d. So this is going to equal, we want that side of the equation to equal 1.8. Well, what values of d, when I put them in here, give us a value of 1.8? Well, we could do trial and error for a while, or we could just do what we've learned before. Let's just move the 1.8 to that side. So this side is equal to 0. I get this, and I get a minus 1.8. Now you might be wondering, how do I factor this? It doesn't look like I can factor anything here because I have decimals. Well, we can just try common factoring. Let's common factor out the coefficient here so that we have just d squared by itself. So let's divide by -0.2 for all of these. Now I'm doing it by a negative because our first term is a negative, so might as well common factor out the negative if I can from that first term. So I'm going to get minus 0.2 d squared here, and then 2 divided by -0.2. I get minus 10d. Negative 1.8 divided by -0.2. So 1.8 negative divided by 0.2 negative. And again, I'm just doing that on my calculator. Negative 1.8 divided by -0.2. I get 9. And this is going to be positive 9 because the two negatives divide to give a positive here. So all I did my common factor, and just so happened my common factor was -0.2. Just happened to be the term, or the value that's in the front here. Common factor, bring my common factor to the front, and then divide all of these by that common factor. And now I'm just doing a factoring here. So I can use decomposition if I want to. Because my first value here for d squared is just 1, I could just do my sum and product. So like two numbers that multiply to give this, that add to give that. numbers that multiply to give 9, 1, 9, 3, 3. But they have to add up to give negative 10. Well, if I make both of these negative, well, these will still multiply to give positive 9, but they'll add to give me negative 10. So I can rewrite this as, because I know my two factors, x minus 1, x minus 9. So then if I get these factors, make them equal to 0, this, and I isolate for x, we get x equals 1 and x equals 9. So what does this mean? Sorry, I changed this to the letter, these should be d's, but I just changed it to x out of habit. So what do these mean? Well, our horizontal distance then, when the dolphin has reached a height of 1.8, is at 1 second, and at 1 meter and at 9 meters horizontally. What does that mean on our graph? Well, it means at 1 meter, the dolphin's at 1.8 meters, and then at 9 meters, this dolphin is also at 1.8 meters. So yeah, it makes sense that the dolphin can hit this height twice, because it's probably going to hit it once on the way up, and then also on the way down again. We're going to get to 1.8. So therefore, at what horizontal distance does the dolphin reach a height of 1.8 feet? Dolphin reaches 1.8 feet at a horizontal distance of 1 meter and 9 meters. Oh, sorry, 9 feet and 1 feet. Sorry, used to using our metric system. So everything is measured in feet. So they reach a height of 1.8 feet at a horizontal distance of 1 feet and at 9 feet. I could check my answer by putting these values back into my equation. The left side should equal the right side, but I'm not going to, because I'm pretty sure these are right. So there's a homework at the bottom. Try some of these out. You should be noticing that this is very similar to Chapter 2 and the previous sections, where we're just getting our equation, factoring, setting them equal to 0, and then solve for that variable. So in your homework's at the bottom, give it a try, and thanks for your time.